Oh, there's some branding. Hill Helicopters. Wow, this already feels so much more legit than the DC one. Ay, there it is. Oh man, gonna slow down and take this in. Production Center 1. Whoa, we're in for a treat today, I think. Look at that. Do they have a pilot yellow parking spot? No, I don't see one. I gotta check with Jace about that. Oh man. Woo. Ruben!
Hey, here we
How
are.
are you, my friend? What do you think?
Wow, production center number 1.
Isn't this nice?
There it is.
Unbelievable, man.
Hello,
It's the man of the
chaps.
hour.
Welcome.
Hey.
Welcome
How
to
are
Hill
you, my
Helicopters.
friend?
Come and have a look
How
at
are
PC1.
All right, so let's go. Oh,
Right.
now that's a showroom, eh?
So this is reception, and then out through there is the showroom where both the helis are going to sit.
Wow.
There's one.
This is nice. Man,
Beautiful.
what a place for people to come to now, eh, Ruben?
I like the idea that it's all glass, right? The first
Yeah.
impact that you have is the heli, right?
You see the heli first, and then we gradually reveal all the things that we've done to manufacture it behind it.
Yeah,
Take people through that step by step, just like
Fantastic.
building a helicopter.
exactly. So it's set up in kind of a pattern of the way things are going to move through the factory.
Yeah, pretty much. There's a couple
yeah.
of zoned areas, but the flow of materials through the factory and the flow of processes through the factory is all logically laid out.
Okay.
But we'll get into that. We'll show you that piece by piece.
Wow.
You know what the glass reminds me is that the transparency is the culture of the company.
Definitely. Yeah.
It's the first thing you see,
It is
the
true.
heli, straight through production.
Yeah.
Yeah.
Well, you can see it straight from the parking lot. You can see
That's
it from outside all the way through to what we do.
Yeah.
And what you'll see today is what we show in the videos is exactly what's here.
Yeah.
You know, what you see is what you get.
Yeah, I feel at home already. I've seen a lot of it on video, so.
Show us around.
Let's go.
All right, Jace. Well, we're gonna have to save the candy for last. We'll look at the helicopter.
Yeah.
There's some new things that you want to show on this, right?
Yeah, we've done a bunch of new stuff on the heli, but we'll come back to that later.
Okay.
We'll go and have a look at how we build one first.
All right, sounds good.
So we've got a hangar for the prototypes going in here.
Okay.
So the flying prototypes will live in there. In the meantime, secure storage
Okay.
for a lot of the modules as we build them, get them off the shop floor, out of the mechanical build line,
Yeah.
stored in there, ready to be built over in. This messy space at the moment is the last of the build-in storage areas.
Okay.
So once that's cleared out, that's where we'll be assembling the prototype aircraft and then zero series aircraft after that.
Okay.
Yeah, and so bits and pieces stored in there,
Yeah.
built there, and then the prototypes in there once they're built. Over the other side of the factory over there, you can see the test labs going in. So
Yeah.
high-speed test lab, speed reduction gearbox test lab, and then the empty space at the end is where the structural test rigs are going as well. So
Okay.
Can
So
I
Ruben,
store
this
one?
is-
Sorry, can I store one?
Two.
Two?
too easy, you'd squeeze 3 in there.
Okay.
Place
So this is going to be a very special place here, Ruben, because
I'm gonna
you
be
and
here.
I are going to build our first
be
helicopters
here.
right here.
Under very close supervision.
Very close supervision, yeah.
Come on, Jason. Very close supervision.
You don't trust us? Come on.
So again, we've got goods inwards here. So at the moment we're using this for the existing mould tools. So
Okay.
prototype moulds for doors, cargo doors, panels, and the bits and pieces that we've already built. Some of these are being changed out at the moment for the new
Yeah.
patterns and moulds. And then this behind you, we'll come into this section later, but this new building here is the new laminating shop. So everything that's manufactured out of composite and the helicopter is made in there.
Yeah.
From goods inwards through that door, through into the kit cutting area, through into the laminating area. This little area here is an airlock.
Okay.
So in there,
This
all
is where
your
Famous
outside,
Dave lives,
all your
right? This is where
outside
his bed is.
clothes get taken off. Your
Change clothes there?
Yeah, your suit and your clean shoes and everything, all that sort of stuff to keep it in a dust-free environment.
How many molds do you have there?
Oh, here at the moment there's probably about 50, 60 at the moment. There'll be a lot more than that.
How many you figure it's going to be total?
Oh, I don't know. At the moment, we'll have loads and loads and loads. There's types and then number, so we'll have multiple sets of multiple molds. Here's the boss.
Hey, Mark.
You
Good
okay?
to see you, man.
Oh, yeah, you all right? You all right?
Yes.
Good.
Good to see you.
Okay.
Yeah. Very nice. It's progressing so quickly.
Yeah.
Another week and a bit, and should be done.
Yeah.
Hopefully. A bit clear up then.
And then this, under this lot here, this is your, well, our casting equipment. So we're building the casting lab at the moment.
Okay.
So all the stuff's been pulled out of the casting lab. You can go in actually.
Okay.
All of the electrical power and stuff is in there in the back.
Yeah.
So this is a
this is
very
casting.
fireproof room for obvious reasons. So all the power and infrastructure is at the back. So we do everything in here.
Okay.
Everything from the wax assemblies through to the block and slurry moulding,
Yeah.
curing all the moulds for all the really critical engine bits like turbine blades, nozzle guide vanes, bearing housings, casings, all that sort of stuff. All of that's made in here.
Okay.
And then at the far end down there, that's where we do all the super alloy casting, make the precision cast parts of the engine out of exquisitely complicated materials.
Yeah.
And then once that's all ready to go, goes off. We're heat treated externally at the moment, but eventually that will come in as well, I should think. And then once we've done that, over across the way into the machine shop to be machined, all the mating surfaces done, all the mechanical details added, and then it's ready to go into the mechanical assembly area. So
this is going to be a very, very important room.
crucial area. This
Yeah.
is one
This
of
is like the heart of the
it's like
helicopter
a
right here.
sovereign capability. This is to be able to
Yeah.
do this stuff is the heart of the
Yeah.
cost base for
Yeah.
the helicopter. So
Exactly.
all these really difficult things like making your own castings out of all the materials you need to use, making your own patterns and molds, these are all areas that if you don't control, it just builds in layer and layer and layer of cost that you can't live with. So, and it is
Temperature controlled? No, this one?
no, this
No.
one won't be temperature controlled because
Yeah.
we've got ovens up at crazy
Right.
temperatures and furnaces and things. It's ventilated and it'll have some environmental control just to keep the atmosphere bearable for the people, but we don't have to temperature control it like you do in the machine shop.
What's the target date to start here?
The room will be finished this side of Christmas,
Right.
and then we've got to wheel the kit in and we'll be starting 2nd of January when we get back to work.
Nice.
Nice to see.
And we've got really good at building these rooms now. So
Yeah.
none of this existed less than a week ago.
Oh, wow.
So
right?
this is and
They're getting quick.
it's all been done by us and a small team of contractors. So
Nice.
we get all of these things up very quickly now, and
Yeah.
we've vertically integrated everything. It's ridiculous. We've become a building firm as
You
well.
really
Never
actually brought in
intended
your own
I never
team?
intended to do that, but
Wow, eh?
yeah. Well, some of the shop floor lads that we've got that
Yeah.
need the facilities, we've used some of that
Okay.
skill base to get some of these things built.
Oh, interesting. Great.
Right, let's.
You're taking vertical integration to the next level.
Yeah, I didn't intend to, but
This
I
is a
have.
new one, right? Last time I
Yeah,
was
so
here,
this
it's
is
not
the
here.
this is the trim shop. Come on in.
Okay. Go
Trim
ahead.
shop. Go ahead.
Oh, thank you. Okay. Yeah.
So
Okay.
this is
a
this is
proper
what we call
woodworking shop.
yeah. It looks like a woodworking shop, right? So it's the pattern and trim shop. So
Yeah.
what we do in here is all of the dusty, horrible stuff that you need to do to create the molds and the patterns for the composite parts.
Yeah.
So a lot of the composite materials come in as slabs of foam and model board. Sorry, the composite mold and pattern materials come in as big blocks of polystyrene, big blocks of model board, epoxy model board, and that sort of stuff. They get glued up like a wedding cake,
Yeah.
and then they get rolled out of that door at the end, picked up by the crane, and dropped onto the gantry mill, which you can see just at the other end.
Nice.
So this is another example of the end-to-end nature of what we've had to do here to control
Yeah.
the costs.
Yeah, yeah.
You know, when people say you can't do a helicopter for this price, but you can, but you've got to do all of this.
Yeah.
And doing all of this is a really big job.
Yeah. Yeah.
But here we can take raw materials, even for our molds, in,
Yeah.
and then machine the molds, and then we're just adding raw material for the parts and the labour involved then to make aerospace grade parts in-house. So bunch of woodworking machines, bunch of extraction systems and air conditioning systems.
Yeah.
Steve's working on some molds, trim molds there for windows. Yeah. So I think
Nice.
that one is a side door window, I think.
Okay.
So that's a former, so you can put the formed polycarbonate on the top of it,
Yeah.
and then back on the CNC machine to go and trim it out perfectly, so it fits perfectly when it goes on the
Right. Yeah.
when it goes on the aircraft.
Nice.
Yeah.
So this room is mostly dusty all the time, right?
Dusty, yeah. Working with the patterns and mold materials, and then when we do some of the trimming, so once your carbon panels have come out of the cure process, they've got to come and be
Come and
trimmed
do
to
trim
finish
up.
shape and
Okay.
cleaned up, and that's all done in here as well.
Is
So-
some of the trimming still done by hand then, or most of it's going to be done by like a robot, CNC kind of
It's a
thing?
mixture. Some of it's done, the precision stuff's all done on the CNC machine, and could subsequently be done by a robot as well. It's the same technology.
Yeah.
But at the moment, a lot of the prototype stuff is just done by hand. And we're doing some other things. I'll show you when we go into the shop next door. We're trying to do some net edge details. So we're moulding in like a carbon bootlace at the edge of the doors and panels, so they come with a proper bead at the end of the panel like you get on a car.
Nice.
So that we don't have to trim those, and we don't have an exposed cut face of composite that can get moisture in and start to open out the laminate over time. So we're doing a bunch of things. We're cutting out as much of the trimming as we can. So this is really about mold prep and some limited trimming with the prototype stuff.
Nice.
So if we head down here, we'll go out the side door, but if we head down here, I'll show you the gantry mill.
Yeah.
So we'll come through here separately, but inside here, this is the production control office.
Okay.
So all of the production engineers that control everything that goes on in here, from how all the machines are operated, the flow of material, everything, they all live in this building that's attached to both the machine shop and also the composites facility.
Yeah.
So
here it is.
Beautiful one.
this is the gantry mill,
This is
and
new
this
gantry
is the
mill.
crane that feeds it, right?
Wow.
So you'll probably remember from when we did the first generation fuselage, some of the patterns and the tools are massive. Right?
Yeah.
And massive is heavy.
Yeah.
And so we have to be able to lift these things. So they come out of the trim shop on rollers through the roller shutter door into this holding area. They get picked up by the gantry crane over the top and lowered in through the roof on the gantry mill in there.
So the roof opens and closes?
The roof opens.
Yeah.
The roof
Amazing.
opens. So it's like a bellows. So this is the new gantry mill.
Yeah.
And basically anything that you can fit on that table, we can make in any shape you like. So any three-dimensional form we can make on here. So this is probably the most flexible and important machine we've got in the whole factory, because this makes essentially all of the patterns for every part we make out of composite. It makes a lot of the trimming tools and jigs and fixtures. So this polystyrene stuff you can see on the bed at the moment, all of those bubble fixtures that you've just seen with machined on there from here. What you can see at the back of the bed over there is a foam block. That surface that we've machined in there is the actual shape of the front of the carbon bucket that lives within the crashworthy seat. And then over there, we're halfway through machining a series of foams with the latest comfort surface geometry and different foam thicknesses, so we can do the final pass at the comfort trials on the crew seat before leather cladding those and signing those off. And so we do that sort of stuff here as well. And then of course, finished windows we trim on here, and some of the composite panels we'll trim on here to get a really, really precise finish on all of the parts. So this machine basically unlocks our ability to produce any of the composite, plastic or any other parts that we need for the whole helicopter. We'll also make the rotor blade tools on here as well. So that's
So what materials
that's one
can
of the
you
next jobs.
trim here? What different materials?
So anything, any of your normal prototyping materials, so any foams, any model boards,
That type of material, which is
any
holding
wood-based materials,
That's the
all that
foam,
sort of
right?
stuff. These foams here, these are
It's
foams
not like a
as well.
cut style, right? It trims with cutting, like a knife.
Yeah, so this is the head.
Oh, it depends on the head, right?
And it picks
Okay,
up any one of these
that need to
tools.
go on
See,
first?
Misha, different tools here, right?
Yeah.
One cuts, one hold, does hold.
Yeah, so
another one.
you use the great big one at the end there, and it'll go in, just cut loads of stuff away. And then we use ball nose cutters, so ones with a round end, to come and sculpt out curved surfaces.
Can it swap out tools on its own, or
Yeah,
not? Yeah.
So it just comes down here and picks up another tool from down here. This is called an automatic tool changer.
Okay. Yeah.
So it'll the program to make these parts consists of lots of tool paths with different tools, and it'll just rough out using a big one, then go and put that back and fetch another one, and then do the fine detail, and then put that back, and then pick out the tiny little fillet radiuses as the last step. So they're really incredibly flexible and sophisticated bit of kit.
I'm curious. Do you have to program the change of the tool, or it knows what tool to use depending on the?
So there's a whole
fine-tuning.
there's a whole suite of software that sits between the computer-aided design stuff where we model the shapes that we want, through to the control of these machines. So the production engineers will show you in there. The production engineers take the CAD models, work out how to hold it on the bed of the machine, and they can go and create different cutting paths and different cutting strategies using some algorithms and pre-built routines to simplify it within the CAM software, computer-aided manufacturing, and that's all semi-automated now. So it's really sophisticated. It's really, really sophisticated. So
I'm feeling nice.
You're ready to fly?
I'm ready to fly. Let's go.
Did you see? Did you sit in the last one?
No.
Oh, you got it.
So those foams don't quite fit that seat. So we've just put the latest version of the carbon into the backrest of that.
Okay.
And those blanks of foam I showed you out there are waiting to come back on here and be machined.
Okay.
So that back profile you can see there doesn't mate properly with this seat, so we've adjusted it so that it fits perfectly.
Okay.
You don't have
this
the leather
foam,
version yet, right?
This foam is probably 2 or 3 times as stiff as it needs to be.
Okay.
So this is the carbon-based foam that's really, really, it's really flame retardant. Yeah.
It's much better, right?
Yeah.
Well, I did try the last one. This is similar to the last one you showed me last time.
So the
last version.
So there are some subtle differences between this and the last one.
What did you change?
So the main difference is the curvature across the lumbar support, across your back. So you'd have felt it pushing your kidneys on the last one, and we've backed that off. It's much flatter across the seat back now. Yeah, and that one, I haven't sat in that myself yet. You beat me to it, right?
Sorry.
But that one
Jason,
there, the seat
down,
pad,
please.
The seat
the
is
seat's
yours.
been just tipped up a little bit at the bottom because it was slightly too flat in the previous one, so it didn't give you quite enough support behind your legs.
Yeah.
And again, that's masked as well because this foam's too hard at the moment. It's the wrong grade. When you put the softer foam in, the bones in your backside will put most of the pressure at the back of the seat, which will make you rotate backwards a little bit, so it'll give you a bit more support under the backs of your legs.
Yeah.
The only frustrating thing with doing an aircraft seat where it's one size fits all is for most guys, that seat pad will be a little bit smaller than you'd want it. You want it to be a bit longer, but if we do that, the smaller girls that we've got, it'll touch the back of the knees and be really uncomfortable. So you can't really win with that. There's a limit to what
so many details.
Yeah, there's a limit to what you can do with a single piece.
Yeah. You want to sit on it or not now?
Well, I haven't tried it yet, so I suppose it'd be rude not to.
Is that the height that it'll be in relation to the floor?
It's 15. It's that far too low at the moment because we've remachined the profile and pushed it down. So put this on another board that thick, and it will be the right height relative to the floor.
Yeah.
That's a lot better than when I tried it the other day.
Yeah.
That's made a huge difference.
Yeah.
Jason, when this is in production, how quickly can you do a seat?
We'll be making
roughly.
Well, it depends. These prototype seats are going to be hand laminated. The final production version will probably be press cured, and you could cycle the skins in that in minutes. To make the structure.
But you have to cut it, right?
So you'll still
the cushions, you mean?
The cushions.
No, the cushions will be moulded.
Molded.
Yeah, they'll be moulded. That'll be a few minutes again.
Wow.
To mould those. These have been. You couldn't do that in production. It ties up a big machine like this for far too long. They've got to be moulded.
So in production, what's going to be made here?
In here, so this will look after tool maintenance, pattern maintenance. It'll probably trim the windows as well. It'll trim all of the windows that we produce here. Yeah. Yeah. So they come in on a sheet, and we have to just put some little cuts in the sheets so that it forms properly. And then once we've done that, you'll see when we go upstairs. In fact, there's some over here. Come and have a look at this. So the material arrives in sheets here, and so we put these little cuts around the sheet. Yeah, and that helps them to avoid having all the excess material around, and it helps the sheet lie over the tool properly when we heat it up and put it on the tool. Okay. Yeah, and then when you come over here, if you look at this one's a front window. So that's the trim line that you can see in there.
Okay.
So that's where you trim it to.
Yeah.
So we've got to make the tools big enough so all this wobbly stuff, which is where the material, if you it's like wrapping a Christmas present. If you took a piece of paper and draped it over this, by the time you get down to the bottom, it's all puckered up. Yeah. It's no different. So we have to form this onto the mold and then cut off all this excess. So the CNC would come and cut that.
Yeah.
So this particular one, they let it get too cold, so it hasn't formed.
I was going to say, I can still see
Yeah.
rippling
This
here.
isn't right yet. All of the side windows are done. They're perfect.
Okay.
This one, we actually need the tool to be a bit deeper to make that one work. So we're on with that at the moment.
Nice.
And then so that's what the trim fixture looks like. That's one of the forming fixtures, so that when you get it on the tool, you've got a thing that can apply pressure in all the right areas to get it to conform to the tool properly. Yeah. And then there's a mixture of drape forming, which is what this is, and vacuum forming that we use for the different windows.
Okay.
Yeah. So this is a side door. So it hasn't got, it's only really one-dimensional curvature. It hasn't got the stuff, so it's a lot easier to form.
Way easier, yeah.
But even so, you get off the mould a bit, look, and you can see where it's puckered because there's too much material there.
Yeah.
But this one, literally, we pulled it out of the oven, laid it on, and it just lay straight down onto the mould. It's second attempt, and it came out perfect. And it's covered in dust and it's dirty in here at the moment. But when you look at that under a stripy light, you can see that it's followed the curvature properly. It's really, really good optically.
Nice.
So that's composite. So that's the manufacture of all the patterns, tools and moulds, and then trimming of finished parts.
Yeah.
We'll go just across the road there.
Yep.
Is the laminating shop. So you take your finished moulds, and then we put the carbon in to make parts there. Okay. But before we do that, we'll go and have a look in the machine shop.
All right.
I like this.
Yeah. So
nice.
This is the production control area. So every machine in the machine shop is hooked up for Factory 4.0.
Okay.
So all the machines tell you exactly what they're doing all the time, what they're working on, what the status of the job is, whether it needs any help or attention. We have that here on the control area here, and also in the production control office where they're managing all of this all the time.
Right.
So some of these machines have come with us.
This has come a long ways, eh?
Yeah, with PC1. So here.
Whoa.
Is this all fine-tuned now?
Yeah.
Yeah.
It's all aligned,
Finished.
running. That's producing turbine blades at the moment. So these are turbine blades that we're going to go do all the grinding development of. So once you create a blade, so it starts as a big cylinder of material like that.
Yeah.
We machine all of that profile out.
Yeah.
So that's essentially, if you cut that off at the bottom there, that's essentially the shape that we would cast.
Okay.
And then we're using these ones to go off and develop the grinding processes to put the fir tree root in it.
I got it.
Because that stuff's ultra critical. The geometry's got to be perfect.
Yeah.
The surface finish has got to be perfect. So we developed all the grinding wheels, the grinding machines, the fixtures, everything.
Yeah.
So we've got to go and just get the machining parameters set up for that. So as soon as the cast blades come off, grind them and we're ready to go for the test engine.
Okay.
So we're making a full set of those so that they can go through.
What material is
And
this?
this is made out of the same material that the real ones were made out of?
Almost. It's a very close material. It's not quite the same.
Okay.
This is a forged version of the material rather than a cast material.
Okay.
The cast materials have got similar properties, but much better crete properties for the higher temperatures.
Okay.
But they're really, really difficult to machine. So
But as far as grinding and machining goes,
it's representative for that.
representative of the same thing?
It's representative for that.
Okay.
All the things that are important to grinding are a very close analogy there.
Yeah. Wow. Cool.
Yeah, so that's turbine blades on this one.
Yeah.
This one's just finishing off a starter generator housing.
Okay.
So
how many of these are you making right now?
So we've made 5 sets of starter generators.
Yeah.
So one of the while we're waiting for the casting facility to come online, we've used 3D printing as an analogy for the casting. So we 3D print what would come out of the casting shop and then finish machine it.
Okay.
And when we finish machining it, they were warping for a number of reasons. So with this one, we've machined this from solid, and we're gradually backing off the wall thickness. We think we've gone a bit too aggressive on thinning down the wall thickness to make it really light. And it's lost a bit of dimensional stability that for something spinning that fast is really important.
Yeah.
But while we've been machining that, we've managed to machine one of the cast ones perfectly as well. So we've got a cast one that works, and we've got that one as well.
Okay.
But we're going to use this to gradually thin the wall out, the main cylindrical wall that contains it, to look at what the optimum is for manufacturing, because we don't want to make these things so difficult to manufacture that everything takes ages.
Yeah, exactly.
So we're just trying
How
to
long
do
would
that
this take
trade-off.
right now to run through here?
This is because we've machined that from solid, which you would never do.
Right.
This has been on the machine for about a day.
Oh, okay.
But most of the time is what it's doing at the moment is delicately picking out the cooling fins,
Okay.
actually whacking out the material out the centre,
Yeah.
and that took a couple of hours. It's not
Okay.
it's not a long cycle.
Okay.
But in terms of the real one, where you deliver something that's almost the right shape as a start point,
Yeah.
that'll be 15 minutes, half hour, something like
Okay.
that. Really quick.
Okay.
When these machines are in production and they're just putting a particular machine face on, or drilling or tapping some holes,
Yeah.
or tidying up an internal bore, really quick cycle times. They'll be robot loaded,
Okay.
and they'll just be banging through components. So
Nice.
rather than having a drawer like this, there'll be a set of robot controlled shelves at the side,
Yeah.
and an arm will come and just replace the part and then
Nice.
put the next one on, and they'll just run 24 hours a day, 7 days a week.
Beautiful.
So, and all that
This type
stuff.
of machine, right? Same type of machine.
Same type of machine, yeah. This has got an automatic, these can have automatic sliding doors, so the door opens itself,
Okay.
and then it's just a generic robot arm that will come and load it.
Yeah.
And they're all set up to do that already.
Nice.
Yeah, but you can't do that until you're ready to make 50 of them an hour, you know,
Yeah,
otherwise
exactly.
it doesn't make sense.
Yeah.
Um,
Nice.
Then over here we've got the precision lathe,
There's
and
a lathe here,
this
yeah.
is busy. Guys are on a lunch break at the moment. This one's been producing bearings,
Okay.
so bearings for the engine, bearings for the speed reduction gearbox.
Yeah. The actual bearings that are going to
The
run
actual,
in the engine?
the actual bearings that are going to run the engine. We're
Okay.
building those at the moment. So they're on with that, and then on the bigger lathe down here, Mick's busy producing drive shafts, I think, for the speed reduction gearbox.
Okay.
Some more work on compressors,
Yeah.
and some more of these are more tools for forming the combustor,
Okay.
and some more bearing components that they're producing.
Wow,
Those
nice.
are the planets out of the main rotor gearbox. Yeah.
The actual ones that'll be in the final testing gearbox?
So, no,
or-
these ones were ones that we did to get the surface finishes right.
Okay.
So those ones haven't been hardened, I think. All the stuff that's on test is out being hardened at the moment,
Oh, yeah.
and then it'll come back and we'll do the final cuts.
These
on
will run together?
Yeah.
Like this or
No, if you remember, there's 3 of these, and
yeah.
they sit around
Right.
a sun gear, and then there's a ring gear around the outside.
Yeah, yeah.
Yeah. So
Weight will be pretty much the same.
yeah.
Yeah.
Yeah, these high torque bits, you can't do anything about the weight. It is what it is. We work the material
tough.
as work the material as hard as we can. We take as much out as we can, and then after that, it is what it is.
Yeah.
So, but
So
it's
what's your guess? What would this cost if you would outsource this? Like a part like this.
uh,
What's your estimate? Just a rough estimate. What would this cost?
couple of thousand, something like that.
A couple of thousand.
From the supply chain.
From the
supply chain?
existing supply chain, maybe
Yeah.
a little bit less, 1,500 to 1,000.
We can do this for what?
A lot less than that. Yeah. Yeah, a lot less
Unbeatable.
than that.
Unbeatable.
I'd say 25%, something like that, 20-25% for those parts in volume when we're knocking them out.
Volume.
Yeah, yeah.
When you're doing bits and pieces, nobody,
Yeah.
nobody wins with that, because all the time's in the staff standing around and
Yeah.
changing stuff over,
Exactly.
and everybody pays the same for people. Everybody pays the same for machines. Everybody pays the same for materials.
Yeah.
So, but when you've got a highly utilised machine shop with parts on there all the time, the costs come tumbling down. And when you've cut out all the middlemen as well,
Yes.
that need to pay for their own businesses, then the
Exactly.
savings come from that. So,
Yeah.
and remember, the production process for a gear, there's about 30 different stages in
Yeah.
that. So if you're not careful, there's 5, 6, 7 organisations involved that all have to make a margin, all have to insure, all have to have facilities,
Yeah.
and that's the stuff that you're cutting out by being able to do it yourself.
Yeah.
But you can only do it yourself if you've got a big enough volume to be able to justify keeping these sorts of machines busy. Once you can,
Yeah.
it's a no-brainer.
Yeah.
Yeah, volume for that.
We've got enough
Yeah.
volume.
Yeah, we've got the volume.
Yeah.
We've got the volume.
We got lots of helicopters to make, Jason.
Yeah.
That's good.
So they're just changing over that machine for the next set of parts that are being made on there.
Yeah.
And then I'll find out. What are we making on here, Mick? What's next?
Just finishing off the glue fixture for the bearings.
Okay.
Just going to make the plunger for the centre.
Yeah.
The locator.
So the other thing about making stuff yourself is you don't just make the parts that you want, you have to make the thing that holds the part on the machine,
Yeah.
and all of the jigs and fixtures and things, and that stuff becomes exorbitantly expensive if you're not doing it yourself. So when you're making things to tiny tolerances like bearings,
Yeah.
you can't clamp them like you would on a normal machine.
Yeah.
They have to be held axially. You can do that magnetically, or you can do that with other means as well.
Yeah.
And that means that you don't squash them out of round and then machine them round and then release them again. They're always just held gently axially.
Yeah.
So we've had to get into all of that to be able to make gears and bearings and things to the tolerances that we need to. But you've just done another batch of drive shafts, haven't you, for the speed reduction gearbox?
There's a drive shaft ready to go out for hardening.
Okay, yeah,
Yeah, there's one drive shaft.
yeah. So these drive shafts here have had a first machining op on them,
Okay.
and then they'll go out to hardening, and then we'll come back and finish machining them, because they have to have splines, internal and external
Yeah.
splines, so you have to harden them for that.
So these are engine drive shafts, right?
Yeah. So this is the drive shaft that sits underneath the engine,
Okay.
and
Yeah.
it comes at the end of the speed reduction gearbox, so it's turning at 6,000 RPM.
Okay.
And these little tags on here are the ones that your Hall effect sensor reads to give you your N2,
Okay.
and also your torque. Yeah.
Okay.
So very, 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 very important parts, and
Yeah.
lots of little detail on the insides.
Yeah. And
Yeah.
that got lathed out? Like
Yeah,
it was a solid...
this started as solid, didn't it?
Yeah.
Yeah.
Started
And what we got the wall thickness down as now on these?
That's 2 mil, that's one of the thicker ones.
Yeah. And what are we down to? What's the thinnest?
One goes down to 0.8.
0.8
Wow.
millimeters over that distance.
Really?
Yeah.
Wow.
Which is really, really difficult.
Unreal, eh?
Thanks, mate. Yeah.
Yeah.
So
Huh.
and here's some of the other bits as well. So you've got your internal shaft. That's what we've just been looking at.
Okay.
Reference shaft, and another shaft down the centre of it as well.
Okay.
So
This goes inside there?
yeah,
Ah,
they all
okay.
sit inside each other, and then some of them are loaded, so they twist.
Uh-huh.
Others rotate and don't twist, and then you've got a cover that goes out, goes over the outside and
Yeah.
holds the speed reduction gearbox to the front of the engine.
Yeah.
But I'll show you that on the engine up there.
Okay.
So, and all of
Nice.
this stuff made here, and then
It's a lot of holes to drill.
yeah. So I'll show you the laser welding cell in a second.
Yeah.
But you remember the manufacturing processes
Yeah.
for these?
Yeah, yeah, yeah.
That they start as flat sheet, cut out
Yeah.
into strips, rolled into rings. Then all these leaves, if you look at these here, these little gaps that you've got in between,
Allows
we have
the
to
air
create
through.
those to blow the air in to create a thin film of cool air
Yeah.
to protect the sheet from the combustion gases.
Yeah.
So we have to roll those, we have to roll form them, then we have to jig them, then we have to laser weld them, then they have to be drilled. There's about 2,500 holes to go in those.
Wow.
So the
Temperature of this was going to be not
really hot. That's really
Super
hot.
hot.
So the gases in the combustion chamber, the gases come out of the combustion chamber after they're fully mixed at over 1,000 degrees C.
Wow.
Yeah, so it has to survive in that environment. It's extremely corrosive.
Yeah.
It oxidizes like crazy, and so these materials are incredible materials.
Yeah.
And then we have to protect them even in that environment.
Yeah.
So, and we have to support that combustion chamber really carefully, because the material's so weak at those temperatures
Right.
that any kind of meaningful loads would just distort it over time, and then you lose the aerodynamic shape and it just doesn't work anymore. So there's a lot of technology goes into that. There's a lot of technology in the combustion system, the fuel injection itself,
Yeah.
before you even get to the things that everybody thinks are the sexy bits of engines, the compressors and turbine blades and stuff.
Yeah.
It's actually all the little details,
Yeah.
like how you live with all the thermal expansions, how you live with all keeping the right clearances and gaps,
Yeah.
how you keep oil
Yeah.
in your bearings when the shaft's spinning at 50,000 RPM, and so it's
Right.
those things that consume all the time and the effort. The core turbo machinery bits at this level are relatively standard fare. It's all the other stuff that nobody ever talks about
Right.
that are the difficult things. Yeah, casting something like that in
Yeah.
one piece.
One
So,
piece.
Yeah, so that's
Wow.
that's a
This one has been cast, or this
What
one's
was this
machined?
one?
So that
Yeah.
one's rapid prototyped.
Okay.
So we cast it. So there's four things that we're going to cast.
Yeah.
As soon as the casting room's finished off, we can fire up all the machinery.
Yeah.
We've got to do turbine blades.
Yeah.
That's urgent because we need to get the grinding done on them. We've got to do nozzle guide vanes. That's really complicated because this is a crude representation of one here.
Okay.
But you've got the rings that support the nozzle guide vanes. Then you've got the blades with all the complex curves, and then we've got cooling passages in them and EDM drilled cooling slots at the back of them. All that needs to be done in one piece, right? Because it's the only way you can make them survive structurally.
Yeah.
So we're doing a nozzle guide blades, nozzle guide vanes. Then the thing that sits in the middle of all of this to hold the shaft, the bearing housings, they're really elaborate bits of mechanical engineering because they have to hold the bearings, they have to provide the static components that the labyrinth seals connect to trap the air and oil in the right places.
Yeah.
They have to provide all the passageways to get the oil from the outside world into the bearings and the rotating bits, and they have to provide the passageways for all the air that keeps the core of the engine cool, all in one part. And made cost effectively. So we're doing a bearing housing next, and then we need to do the big casings.
Right.
Yeah, and the casings, although these aren't particularly difficult shapes, they're simpler shapes.
Yeah.
The challenge with these is getting the wall thicknesses down to something that's acceptable.
Yeah.
Otherwise, because these things are so big, they have such a big diameter, a lot of the weight of the engine is in these components. If you don't, a lot.
Is that
I thought it was more.
Yeah, no.
is that what's going to weigh in actual production, or
We've got a variant of that where the weight's about half of that.
okay?
But that's a mixture of
Half.
some elements of it are cast and other elements of it are rolled sheet.
Okay.
So we can get much thinner wall thicknesses.
Okay.
So we've got two versions of this, and which one we go for will depend on how thin we can get the walls down reliably when we're casting.
Right.
Yeah.
Interesting.
Right?
So when we were talking about castings earlier, so this is a good example of what typical machining will look like in production. So you get the cast component with all its major features, but everywhere where you've got a mechanical connection, you'll have to go and dress that face on a CNC machine, put the threads in, dress the flange faces and things like that.
Yeah.
And internally where you've got labyrinth seal faces that you need to hold tight tolerances against, go and do all of that sort of stuff in here as well.
Yeah.
Yeah.
Nice.
Then we've got the tool room up the corner, so jigs, fixtures, bits of equipment to hold parts on the machine.
Yeah.
This is where we do all the tool length settings, so all the collets are there, all the tools are there, all the electronic record of all the digital tools that we buy, because we get through machine tools like nobody's business.
Yeah, I can imagine.
So all of that lives there.
Yeah.
And then we're just about to take delivery of, we've had one new machine come in yesterday,
Okay.
and then we've got another machine which is a mill turn unit. So it can do essentially everything that the lathe can do, and a 5-axis machine all in one operation.
Yeah.
So you can put a slug of material in the machine and have a finished part out without having to move it from machine to machine to machine.
Yeah.
So if you think about the gears, then the gears start life on the lathe to mill the blank. Then they go onto the grinder to have the faces tidied up a little bit.
Right.
Then they go onto the 5-axis to have the teeth cut, or the grinder to have the teeth cut.
A lot of movement going on.
So if you can keep that in one fixture,
Yeah.
your accuracy improves and your throughput improves dramatically. So
Huge.
there's a mill turn unit to go just here.
Okay.
And you've seen the wire eroder before. So if you peer in here, I'm not sure if it's working or not at the moment, but this produces your turbine discs.
Oh wow.
So we machine, this is the bit that holds the turbine blades.
Yeah.
Yeah. So this gets turned on the lathe, then it'll have some 5-axis operations to put the curvic couplings in and things like that. But then these profiles, the female fir trees,
Yeah.
they have to be cut in by this. So this is like a cheese wire
Mm-hmm.
that goes and sparks away those profiles and vaporizes the material.
Yeah.
And we've got some very, very special processes to make sure that we don't locally melt and then recast the material on there, because that'd kill the mechanical properties.
I see
So
water in there. Is that done in water or
it's
no?
not water. It's a special fluid that
Okay.
allows the process. So it insulates the process, so that you can only spark across that. Otherwise, it
I see.
lights itself up.
Yeah.
So that's what your turbine disc looks like, and we finish that off over here.
Yeah.
And then we also use this machine to chop up the super alloy. So When the super alloy comes in, it has to be cut in from big bars into little bits that will fit into the crucible on the casting machine. So you can't cut it because it'll kill cutting tools in no time because it's so hard.
Yeah.
So we use this machine to erode it away electrically.
Okay.
So this is a very similar machine. It works on a similar basis. So they're just installing this at the moment. But in the back of the aerofoils on the nozzle guide vanes, the first aerodynamic component that the hot gases see when they come out of the combustor in the engine, we blow cooling air through the centre of those blades, and that exits out the trailing edge. So we've got to cut slots in the trailing edge of each of those blades to bleed that air out. And so you can't machine it, it's too small, you can't get at it. So we use this machine to be able to electrically die sink those holes into the back of it. So another very, very specialist piece of turbine manufacturing equipment there.
This is a new one, right?
This is brand new. It came in yesterday.
Oh wow.
Yeah. So
Crazy.
hence we haven't taken the wooden blocks out yet.
Huh. Amazing.
Talk about that in a second.
Yeah.
So we're just starting to put the sheet metal fabrication facility together at the moment.
Okay.
So this is where the rolling and the roll forming and the pressing goes on. But again, we're making lots of
Got the Bible here.
combustor
Good.
rings. Yeah, making lots of custom combustor rings, getting the quality and the consistency of this right.
Okay.
Yeah.
Those
That's
looking
come
nice.
on leaps and bounds. So if you remember, we roll them, we roll form them,
Yeah.
and then they go onto the expander there. So we stretch them out so they're perfectly round.
Yep.
And concentric.
Looks
The old ways
solid.
are the best. The old ways
This
are the
looks
best.
solid.
A lot of
I keep
history
saying,
there.
Metal handbook.
I keep telling you, some of this stuff isn't new. You know,
No.
Some of this
Die
stuff-
design, die making practice.
Yeah, it hasn't changed since the Ark.
Yeah.
Hey, you read that, Ruben. You get a job here.
I see that. It'll be a couple of days.
Yeah.
Some easy reading in the evenings. Wow.
And then we've just put this laser welding cell in.
Okay.
So this is all being done semi-manually at the moment.
Yeah.
So we've got turntables. Eventually that will be done with either a robot or a cobot.
Okay.
So you'd have a fixture to hold it, the thing will spin round, and then all the parameters will be locked down.
Okay.
But while we're developing it and getting it just right so it's consistent,
Yeah.
it's best to do that part manually. So we can control the parameters, the feeds and speeds and
Right.
all the welding parameters, and lock that down and then automate that.
Yeah.
So this will get us through all the prototyping, and then we'll add a little bit more automation to do this in volume.
This is where Mark lives.
Yeah. This is
Mark
Mark's
controls
office.
everything there.
This is
Yeah.
your home, eh?
So
Wow.
we'd like to introduce you to the famous sofa.
Ooh.
Mark was on a tight budget when he ordered that sofa, so it's only adequate for children.
You
Were
didn't
you-
build it big enough that you could sleep on it?
I know why you.
So you're asking earlier about how you control the machine. So when the designs come down from upstairs, you get 2D drawings. Here we go. So you get engineering drawings like this,
Okay.
and these are really a set of manufacturing and assembly instructions. So this tells you every detail, every surface finish, every fit, every connection, all the detail you could want to make all of the parts.
Yeah.
So there'll be like a pile of drawings that thick for the whole helicopter.
Oh, yeah.
But what the guys use down here is they use a separate piece of software that takes the 3D models, so the 3D CAD model of the part,
Yep.
and the 3D CAD model of the stock material you start with, and then works out how to cut that using a standard set of tools that we've got on the machine.
Right.
And then what these guys do in here is they control all of that. So this is just a simple mod for the speed reduction gearbox, yeah?
Okay.
So he's got a CAD model of the bit as it's come in, and then it just goes and gives the program the instructions of what we're trying to create, and it will go and work out how to cut that on the machine, and then it outputs a bunch of, it's like a text file with a bunch of G codes. So these are just simple machine instructions that say go to this coordinate with your spindle spinning this fast in this orientation,
Okay.
and it just point to point to point to point to point. So you saw the smaller version of this before at DC1.
Ah.
Hey Nick.
Hey, how
Very
are
well,
you?
thank you. You've got Misha and Ruben with us.
Yes.
Hello.
So
Nice to see you again.
is that the conforming one? So that's one that's representative. So it's It's 3D printed, not cast yet, but
Okay.
it's 3D printed and then machined, so it's really representative
Yeah.
of the process we'll use to make those in production.
Nice.
And that one's now hitting the tolerances even with its thin walls. Yeah.
Yeah.
So is that the one they're going to assemble later then?
Yes.
So that's the one that will be assembled and hopefully run later today.
Wow.
Is it?
Yeah.
How do you test the tolerances? How you make sure the tolerances are there?
So, Nick.
Thank you. I just go from what the drawing is. So I'll put it in there, measure it. So we've got tight tolerances as well as slack tolerances, shall we say. So the drawing tells me what to put in there.
And then how you check?
Yeah,
this-
so
this thing is
the
testing
drawing
right now, right?
defines what the largest and smallest any parameter can be is, and how round, how cylindrical, how in line things must be for it to physically go together and still work. So the design engineers set that as the targets they need to make it work.
And every single
And
design
then-
it shows that?
Yeah, so there's
Everything
tolerances
there,
on
so
each
we've
of
got
them.
H9 on there, which will give me 30 micron tolerance.
Okay.
So quite a tight tolerance.
And then you measure it? How you measure it?
And
This
so
is- this is
that's what this
measuring
machine
right
does.
Okay, and then you get the feedback
Yeah.
digitally, or you?
Yeah, so have you got a report?
Back to the
that you can
program?
show? So we go and we write a program that will go around and probe all of the dimensions that are critical on the drawing. You only measure the ones that are critical, not everything.
Yeah.
So go and measure the critical dimensions. Then we compare what the as-built condition, so what size it actually is, with what they asked for on the drawing.
Yeah.
And then we get a metrology report here, which will just show pass or fail. Yeah,
Okay.
it shows whether the parts are in spec. So every critical part will go through this process. So you'll
Is this
know
room controlled?
temperature controlled. Yeah,
Yeah.
Always the same? What's the
always the
variance you
same.
can have?
Half a degree. So half a degree.
Half a degree, is it?
Roughly half degree.
Yeah.
Nobody can leave the door open.
No, don't leave the door open. In fairness, that's temperature controlled as well. So
Oh, yeah. Okay.
He has the best job. He's always
he's always the right temperature.
Yeah.
even in the UK.
So this is the mezzanine floor.
Yeah.
So we had to temperature control the machine shop, so
Yeah.
we've got to put a roof over it to make that viable. And so rather than just putting a box like we've done over here, we've put a structural floor up here so that we can do some of the lighter manufacturing activities up here.
Yeah.
So we've got glazing, we've got mechanical assembly, we've got avionics, we've got the engineering stores over there. Then we've got the trim shop where we'll do the leather seats and all the interior trim panels. Glazing, we're starting here. So this is one of the new tools. So that's a nose tool. Yeah.
Okay.
So there's a sheet goes over this before it gets formed.
Yeah.
This is basically a glorified pizza oven.
Okay.
Yeah. So you put your acrylic or your polycarb sheets in there.
How many pieces of pizza or how many pizza pies can you make in here?
Well, at the moment it's just set up to do 2 pieces at a time, but we can change the racking so you can get multiple.
Yeah.
We'll end up with the time scale in this process is actually the heating.
Yeah.
Even though if you do a traditional drape form, you need lots of people or fancy fixtures to drape the sheet onto it.
Right.
It's really quick. It's
Okay.
just literally plop and you're done. So you can form these windows really quickly.
Yeah.
So we'll end up with like a great big industrial toaster for these sheets. So the sheets get heated in there, and then they get draped using some of the frames that I showed you earlier.
Yeah.
And we've got that down now for everything other than these very front windows.
Okay.
And that's just a modification to the tooling now to make them a little bit bigger. And we need aluminium tools rather than
Right.
model board tools, so we can heat them and have the tool surface nice and hot. But
Yeah.
So this is the avionics and electrical lab.
Okay.
So we've got Eric on the porting the latest version of the DigiCockpit PFD onto target hardware at the moment.
Okay.
So that's the code. This is the breakout board, so it's the target hardware, but with all of these input boards pulled apart onto separate boards so that we can just jumper lead them.
And these are not your boards, right? These are.
No, these are all ours. We've done these. This is just a development
Okay.
board, but all this stuff is bespoke to us.
Okay.
These are our screens, so
Yeah.
bought the screens, but they've all been packaged for us with the right coatings and everything.
Okay.
This is final. You have
So this is
chose.
final. Yeah, this is all what
Chosen.
will go into the helicopter.
Nice.
So he's just porting the software onto this, tuning it for the hardware,
Yeah.
and then once we've got a stable build of that, then this will go and join the rest of the avionics system over on the pegboard here. So they're just starting this at the moment.
Okay. Yeah.
So all of your wiring loom, so this is where we got to with the wiring loom previously. You've got the other avionics modules up there, so your audio panel, comm radios, transponders. GPS source, AHRS, and outside air temperature probes, and all the other bits and pieces that you need to make it work. So each of these will go in a representative position on this table.
Yeah.
All the cable runs will be done, everything down to how you clip the cables together, the P clips that clamp it to the airframe.
Yeah.
Every conceivable detail
All
will
on
be
this
built
table.
on here first, so that we know it works.
And is this
we know it works before it goes into the aircraft.
size-wise? Is this like back gearbox to the front nose, or no?
Almost. This is longer than the airframe,
Okay.
so it doesn't go all the way to the tail, but we'll just loop that round
Okay.
for that particular run.
So you say that every single one that's going to be produced here could be assembled. The cable will be assembled here.
On this one, yeah. So on this table, so all of the ones for the pre-production aircraft,
Right.
0 series,
Yeah.
and then this whole facility will just be scaled up.
All right, I haven't been in here in a little while. Oh, this is nice.
Right, so this is the latest version of the PFD. Lots and lots of work really refining and polishing what we've got. So
Yeah.
we'll start with the familiar bits. The attitude indicator and the DI are all the same right in the centre. We've got a much clearer, crisper airspeed indicator
I
now that's
love
at the
this.
top.
This is nice.
It just fits with the design language. You've got a nice clear dial, so you've got all of the best bits of analog
Yeah.
and a much crisper display.
Love
So
it.
as with the previous version, you've got your barber's pole there for auto rotation, and you've got VNE. VNE will move along the gauge automatically depending on your environmental
wow.
conditions.
Amazing.
Your power gauge is broadly the same as what you've seen before.
Yeah.
So pull into the green as long as you like, and then into
Yeah.
the amber and the red, and you get the countdown timers at the bottom.
Yep.
During startup, you've now got N1 and MGT will
Okay.
display under there,
Nice.
and
Yeah.
then your countdown timer will be there
Yep.
whenever you're in a power limited range.
Yeah.
You've got your fuel bar.
I love the
at
fuel there
the
now.
bottom.
Yeah, I like
That
that.
can be a percentage or a volume or a weight,
Yep.
depending on what's most useful. Much better tacho now, so a nice big green
Way
range on
nicer,
the
yeah.
tacho. So this is sort of Jet Ranger MD500 style, so fat needle, thin needle,
Yeah,
overlaid.
Yeah.
So you've got a nice big green range for your auto rotation. You'll notice that it picks up just where ground idle is, so
Yeah.
you're making the range as easy to read as possible.
Really
then
nicely
rotor
done.
RPM in the centre, engine RPM down here.
Uh-huh.
And then on the other side, this is the altimeter concept is one that you've seen
Yes.
seen before.
But this is nicer implementation. I
So
like
this
that.
this is much cleaner.
Yeah.
So we've got essentially 1,000 feet
Yeah.
on the scale, a
Yeah.
single needle,
Yeah.
and then every time the needle swings round, the tail of the needle updates
Sweeps
the
up.
needle, updates
Yeah.
the numbers on the other side. So you've always got a 1,000-foot range. It's always 0 at the top, and it works around 100, 200, 300, 400,
So
500 feet.
nice.
So
yeah.
you'll get that perception of vertical rate.
Yeah.
You'll always know where the needle's pointing, so however high you are above sea level, you'll be familiar with your normal height above ground in
Yep.
the areas you fly a lot.
Yep.
And then you've got the digi readout in the middle.
Nice.
You've got your pressure setting in the centre, which you can tap, and that'll automatically pop it up on
Okay.
the IPI.
Yeah.
Yeah, and then you've got a big vertical speed indicator on the side. Again, nice big arc
Yeah.
that shows you the rates that you're likely to be interested in.
Yeah.
We've put the radio and the transponder bar all the way across the bottom,
I like that.
and that just makes it much easier for us to display lists of frequencies. So whereas you've got your favourites, your nearest, and your recently used lists on the radio menu,
Yeah.
and things that's pulled from your iPad as well,
Yeah.
we can display those along the bottom
Yeah.
when you press the list button. So you can press the list button, it'll pop them all up, and you can just tap the one you want to make it current. Yeah, and then transponders conveniently in the centre, ident, mode, and then your squawk code.
Yeah. Yeah.
Engine gauges.
Can
here.
you can just tap the ident for it to ident?
Ident,
Yeah.
yeah, exactly.
Amazing. Yeah.
And then obviously behind this as well, I don't know if Eric set it up for us. Yeah, he has it.
Oh, nice.
So behind this, you've got the video.
That's what a video feedback.
the
Yeah.
video
That
feedback.
looks so good too.
So that
Wow.
it really comes.
But that's
up-
the back camera, right?
So that's the camera in the light at the front.
On the front.
Okay.
Yeah. So that there's a camera embedded in the nose light at the
Yeah.
front, and that's just your pass-through view.
Yeah.
So this big blockage of instrument panel you've got in front of you can just see through.
Yeah.
Basically.
Yeah, yeah.
And we've done demo tests with this with a very simple rig and test flown it.
Yeah.
And you really can approach a point. So you
Yeah.
can approach like a elevated pad.
Yeah, yeah.
And the bits that you can't see, you can still get enough. You still hold a point fixed on that screen.
Yeah.
And stop it from moving up and down as you would on your windscreen. It
Yeah.
works just the same.
Oh man.
So-
And what would be the ability to, where would be the ability to swap through different cameras? Because we have downward facing camera. Correct?
Yeah, so on
And then
that,
a tail-facing camera?
So the intention is that the main camera for this will always be the forward-facing one.
Okay.
You've got a palette of cameras. So at the moment we've got the other screen set up to just reproduce the gauges.
Okay.
But you can have full screen camera modes and there's simple menus on there.
Over
that
there.
You can point it backwards, downwards, or the cabin view, or whichever camera you're picking up on.
Is there any way, this is a suggestion,
Layover.
is there any way that we could have the downward facing camera on here as well?
Yeah.
Because I'm thinking about long lining.
Yeah.
If you're in long line operations. I love this, but this is not going to be practical for somebody that's hovering at 200 feet trying to get a box in a spot. And so to be able to switch the mode, if you're in long lining mode, for example, you switch the mode, and then now you have the downward facing camera. You approach your spot, you're looking down at the camera. You don't even need to hang your head out there because it's a beautiful, nice full screen view. You see, the center point would be where your line sits.
Absolutely. I was really talking about the cameras that are standard fit.
Right.
So for your long line, for the hook kit, the camera fit for that comes with the hook kit.
Okay. Yep.
So for that, we might clear that display out a little bit to give you a better view down,
Yeah.
rather than your normal flight instrument.
Just the little details showing like fuel range here and endurance, the outside air temperature, the ground speed, the length of the flight. I mean, this is just, everything is so nice now. I really like this setup. Jace, well, this has been an incredible tour, man. I don't know what to say.
I'm glad you like it.
This is a facility that is in the 21st century. It's going to make amazing helicopters.
Well, it takes a lot to build helicopters, to develop helicopters, to do it. You've got to have the infrastructure and the facilities to do it. So we've done a lot of work on this over the last few months to get it ready. Now it's ready.
Yeah.
We get back to getting these things in the air next year.
It's impressive how quickly it happened too. I was really
Well, you've
amazed to see
you've
that.
seen a little bit today of what we've had to do to turn this from an empty shell into a factory, and we're there now. So
Here's
to
the
business.
setup for 2025.
yeah.
it is.
To see this thing up and running and just doing parts,
Yeah.
it's going to be an amazing year.
It
Yeah.
is. I'm
And
excited.
we do tours on a regular basis, so if people want to come see this place,
Yeah, every
we can
week.
do that every week. We do a tour, so
Yeah.
it's definitely exciting for people to be able to actually see it in the flesh. You can see it on video, but it doesn't do it justice until you're here.
No, you've got to come and
Every
see
part
the,
of it is.
the scale and the complexity of what we've built.
It's
People
worth
need to see
coming,
it.
for sure.
It's definitely worth it. Yeah. So awesome. Thanks for your time, Jason.
You're very welcome.
I know you're busy.
Good to
so-
see you both.
Yeah. Thanks.
Cheers, guys.